Start recording. Okay. So today we're going to do a 3D game, and it is going to be a like a cat and mouse style game, very basic. So if I just run it quickly, you get a sense of what I mean. So we have a small brown mouse, a circle which represents, or a sphere representing a grey cat, and there's some cheese that you can go to. And the cool things is that you use the mouse to basically control the ball, and the cat is just following the mouse. It just goes to where the mouse's position is as well. So that's one of the cool things. The other cool thing is that we're not doing movement the same way as we did movement last week. So last week we used translate, and that simply moves the XYZ coordinates to some position, right? You translate left a little bit, up, right, you know, in all the different planes, but it's just moving the position, translating the position. This week we're going to be adding forces to do movement. So how these balls are moving is I'm applying a force in a certain direction, and that is moving the objects. So it's using more of a physics-based approach here. And the simple game mechanic is if I pick up the cheese, it disappears, and then bottom left, you can't really see it, it says GG. But like last week, we could have implemented a score mechanism, something like that. And when the cat catches me, so if I just stand still, I die, and now there's an error, which is probably something we should fix. But that's the end of the game, basically. Alright, so that's what we're going to be doing this week. So let me just see. Okay, this did open. Cool. So now if I run this, this was made in a 2018 version, I think I was right. And if I run this, hopefully it runs okay. Hopefully. Cool. Is it running okay? Yeah. So this was just a base converting game that I was trying to make. And some buttons that change values. There was a timer. Yeah. Now I see there is an error, so maybe there isn't something quite right. Okay, so some null references. So some things that do break is... Actually, I don't know. This all looks like it's imported correctly. Let me just run it again. Maybe it was a bug in the actual code, not I don't know, but like I say, there's some sort of error that just needs to be fixed where I'm dividing by 0 somewhere. But other than that, it tends to load pretty smoothly. So this is probably an easy fix somewhere. But yeah, let me not get into that now. So yeah, this is definitely a viable solution to that issue that you had. Okay. So this week though is this mouse cat game. So I'm not going to do it, but I'm sure you guys are pretty familiar or comfortable now with just adding like okay, I'll do one more where I just add like a 3D object now instead of a 2D sprite. And now this is like a 3D object that I can morph into different shapes, and you can see I've made these different walls. So how we do that is by referencing the scale. I am still streaming my screen, right? Everything is perfectly fine on your... Okay. So I can manipulate this guy's size by changing the scale in the different coordinates. I can also click on this I don't know, user interface icon, which is the rect tool. And now I can hover over my shape and like drag and pull it. But all it's doing, you can see here, is changing my Z value as well as the position, because now its center is changing. So that makes sense why the Z value is changing. And I can just morph these to whatever size I want. I can move the camera around, get it in the right position. Obviously it's way too high. And once again, when I want to change position, I'll obviously just use this tool as well, and I can use the move tool. And now I can move it up and down and stuff like that. So I'm sure you guys are all okay with doing that type of thing. I don't want to go too much detail with that. So we'll just leave that there. So all I did was I made a plane. So that's just right click, in your inspect or hierarchy, right click 3D object plane, and then I made a plane. And then I did the 4 cubes to make my walls, and then a sphere. So just right click create object sphere to make my cat, my mouse, and the cheese I did something a little bit different. So what I used to do to get the cheese, so if I just zoom in a little bit, it's not like a perfect sphere. You see it's kind of like a cheese model, even though when we play in the game we can't really see it. To do this, I just went to the asset store, which is another tab that you have here. So you have scene, animator, asset store. And if it's not here, I think you can go to like window and or one of these windows and then open it through that way. And the asset store basically is like all these assets that you can purchase to add different things to your game. Some of them are just scripts, some of them are like 3D models, some of them are like there's tons of different things, right? That you can get 2D, 3D, add-ons, tools, some VFX stuff, a lot of things. But not only are there like items for sale, but there's also free items that you can download. So all I did was type in cheese here, I searched for it, and I specifically set my pricing to be free. And now all of these are basically, okay, well I didn't update that. All of these 3 at the bottom here are free assets that I could download. So this one I've already purchased. It was free, so they still use the term purchased. And I just click on that. It will add it to my account, or my account, which is obviously I have the free version of Unity. This is just a standard free account. I haven't done anything behind the scenes. It will be the same account you guys use. You just need to log in, and I can now import this into my project. So I will import something else because I already have the cheese imported. So you just click import, and then it will pop up with what you can import. Now this is all this package has to offer, so it's not just cheese, it's lots of different things, right? We have materials, we have models, we have prefabs, we have scripts even, textures, but all I want to get, so I'll just click the arrow at the top to deselect everything. All I want to get is, let's say, what you guys want, the beer maybe. So I'll click, so I want the beer material, so that's this guy here. So the material is basically like the skin of the model. I want the model itself, so we click on the beer and you can see a little thing there. So it obviously doesn't have its skin on, so it doesn't look like that, right? It's just like the raw model. The prefab, it's just all of those things put into like one object. Like I think I demonstrated prefabs last week. So it's basically just a prefab like that. I don't know if I need texture, to be honest, but I'll put it in just in case. And that is it. So that's all I want. So then I click import. And now I would be in my assets folder, and you say it's here now, RPG food and drinks pack. And then assets, models, and materials, and all those things that I wanted. So if I have to go to models now, you see I have beer and cheese. So cheese was obviously from when I previously added that. And now this is my beer model. But I want the prefab because that has the like the texture added to it. And now I just drag that and drop it in my world. So it's very small. And now you can see my beer thing here. It has the mesh renderer with the beer texture material, on it. And I could put the cheese texture, material on it if I wanted to. So now it has the cheese material on it, and I'll just make it bigger so you can see it a bit better. That is a beer can with the cheese texture on it. Cheese material, I don't know why I keep saying that. So let me just put the beer bun back on, and you see now this, obviously this material was made for this object, so that's why it just lines up everything. Yeah, so easy as you like to just import assets that are free into your project.
I have a quick question.
Sure.
So you see the shadows on those balls. How come they are, you can see that the balls aren't actually on the plane.
Because
So,
they aren't actually on the plane.
okay, so did you like set a certain value for them to, or wait, I don't know exactly how to say it, but
So
so they'll just keep that height
no,
basically.
no. So I was lazy, and I didn't want to like perfectly line it up. But these balls have a rigid body, so I haven't gotten to that yet. But so when the game starts, because they have a rigid body, they'll fall based on gravity. So okay, you can't really see it there. Sorry.
Okay, I see.
Just yeah, let me just write it one more time just in case someone else missed it. They just fall to the ground like that.
Okay,
Yeah. And my mouse didn't. My mouse wasn't on the game window, so that's why I wasn't moving. Right. Cool. Now
all right.
you could obviously just go and place these better if you wanted to, but I was being a little lazy. Cool. Okay, so a few things that maybe you're not aware of that I did. I added a material to my plane. So in order to do that, I simply made a materials folder. I went into that folder, I right clicked, I said create, and I went to material and floor 2. And I just made one, and I just set the color to be something. So I clicked on the material, came to the color area here, and I could use the eyedropper. So now you see the colors changing as I move over things. But let's just double click on it, and now you got like a color wheel that you can set it to whatever you want. So let's just set it to a green. Oh, that's kind of horrible, I think. Bluish, dark blue. I like blue. And that's what I want. And now to add this material to objects that can't have materials added to them, I just drag it and drop, and you can see now I could put it on the wall, on the floor. I'll just put it on the wall so you see how it works. And now I click on there, and under the mesh renderer you see now the material is there. Cool. Just a few things when you're making this from scratch perhaps. Note that there's box colliders on these walls, and that's because I don't want my balls to go through the walls, and there's a mesh collider on the plane because I don't want the balls to fall through the floor. And then the balls specifically, why can't I click on that? The balls specifically have a sphere collider because they're spheres, makes sense to use that, and a rigid body so that they are like a physics object that is affected by gravity, like I said before, and also collides, will collide into things with colliders. Cool. For my cheese, I also added a sphere collider and a rigid body. Now, it doesn't default come with these, so if I click on my beer, you see it doesn't actually have a collider, nor is it a rigid body. So when I run the game, it just floats in the air. Like that, right? So you would just, if you wanted to incorporate this, you could just add a rigid body as well as a collider onto it. I'm just going to leave that there for now though. You don't need it. Okay, so that is basically the setup of what we got going so far. Now, once again, when you try to make these games, you have an idea. It's always really important to try figure out what the problems are that are entailed with the game that you want to make. So we want to make a cat and mouse game, so a game where you're playing as the mouse, you're trying to get to the cheese, and you're trying to avoid a cat who is trying to catch you. So first thing you identify there, well, we want the cat to try catch the mouse. Okay, so in our example here, the approach we want is that the cat moves to the mouse's position. And how we want to do that is through adding a force. And the only objects that you can apply forces to are objects that have a rigid body attached to them. So that's also why this is important for us to have. So I have done these things, and I am going to basically just walk you through the code instead of typing it at the same time, because I think that takes a little bit more time up. So I would create a script. I just called it cat controller as just a general naming convention I have, and now I'm opening it. Okay, so the idea of adding a force, right? You add in a force that's going to push your object, and you apply these forces onto things that have rigid bodies. So what do we need? Well, we need the rigid body itself. So you could just reference it through using this get component rigid body wherever you use it, but I've decided to store it in a rigid body variable that is local to this script. So I just define a rigid body that is the type of objects that I want, or the type of this variable, and I get that variable, or I get a reference to that actual object, sorry, that actual component. Now the reason I can say this is because I'm going to attach this script to my cat, and there is a rigid body on my cat, so I can say this dot get component. It will look on this object for the rigid body component and return a reference to it, just like I did last week. I think it was with colliders or something, maybe exactly the rigid body as well. So now I have my rigid body. Okay, I can apply a force to it. So if I wasn't sure how this works, you could just Google add force to object Unity, right? And it would come up with the scripting API for rigidbody.addForce. And you could have Googled, if you didn't know about add force, you could like, how do I move an object? And it would either tell you the translate, or some might tell you the add force. And now we see here that, okay, add force takes in a vector, and it's a vector 3D in our case, as well as a force mode. So I'm not going to get into that. That's not super important. And then we can scroll down and we can see, okay, it looks like the force mode is also something that you don't need to specifically set. So here they just say rigid body dot add force and then some vector. Okay, cool. So that's what I have done in my, where is it? Yep. So I have got, so ignore this for a second. I have done is said rigid body dot add force, and I gave it a direction. Now what you might be thinking is, well, let's just use the mouse position. Okay, and I'll explain where I get this mouse position. So this is literally the position of the mouse object. Okay, because I want to move my my cat to the mouse, so surely I should add force with the variable of the mouse's position. So I'm going to run this and show you what happens. One sec. So now you see my cat is going some weird direction to the top left, right? Kind of strange. My mouse, okay, my mouse movement still works fine. Sorry, I'll use cursor for my actual cursor and then mouse for the mouse thing. But you can see it's not working, right? And the reason for that is we can't simply feed in the position of the mouse. We need to feed in the vector direction to that mouse. So that's why I have this line here. So we calculate the direction, which is basically the position of the mouse minus my current position. Does that make sense to everyone? Because we want to get the direction to the target, a vector that points us to the target, and we use it by just simply taking this difference. Now, the way I've referenced the transform is exactly the same as saying this dot get component this dot get component transform dot position. It's exactly the same thing. So maybe use this because it's more accustomed to you, but because once again this transform object is attached to, well, this script is attached to this specific cat game object, I can just reference the transform directly like this. So it's just another way of doing it. Okay, so now let me just explain this component first. So I didn't want to directly reference the mouse, the actual like animal mouse in the game through the cat's controller. I wanted to go through some game controller, and that's what I have here. So I've declared a game controller object, and I've called it GC, and that's just another script. And this script basically has a method within it that allows me to get the position of the mouse. So let me show you how that works in terms of the game world, or in terms of Unity. So I have a cat controller attached to a cat. I have a mouse controller attached to a mouse. And now I have this game controller game object here. And I've attached the game controller script to that. Now this is just an empty game object. So I just went here, right click, create empty, and that's what I did here. So this has a transform, but it's empty, it doesn't have anything else, and it has a script. And what this guy does is basically, it's a way that I can just keep track of everything that I want to keep track of on one game object. Because when you expand your games into, say, more complex things, I have maybe cats referencing mice, mice referencing something else, the cat referencing the cheese, the mouse referencing this. All of these things can get really complicated and a bit convoluted. So the better practice is to say, well, instead of the cat referencing the mouse, I'm going to say the cat must reference this game controller object. And the mouse also references the game controller object. So it in essence is just like a nice uniform location where I can store references to multiple objects. Like if I had a dog, I would say the dog could also be referenced here, and then this guy, because he has reference to the game controller, he can access the dog through the game controller. I hope, maybe I'm not explaining this as perfectly, but I hope it makes sense in that sense. So on my game controller script, I have references to the mouse and the cat. And I'm not doing very much here because it's a simple game. But I have a public method here that says get mouse position, and that just returns the mouse object dot game object, so I get the actual mouse game object. Dot transform, so this would return the transform, and then dot position. So dot position, if we go into the inspector, if you remember, if you go to any object, you click on its transform, and then you see the position aspect or component returns its X, Y, and Z position. So that's what I'm doing here. I'm just returning the position of the mouse. And because this is a public variable, a public method, I can call it on my cat controller because I referenced the game controller, and then I can say GC dot. So if I say like GC, which is the local name of the game controller, I say dot, I can access everything within the GC aspect that is public. So what I can do is in the game controller again, let me just make another one quick so you can see this demonstrated. Public void, so it's going to return nothing, do nothing. Okay, and this is going to just say debug.log like nothing or something like that. Cool, so now on the cat controller I can say gc dot do nothing, and you see it's over here. It's accessible now within this separate script. which is quite useful because I can do communication through that. So this is not really much different to what I explained to you guys last week, right? Just using different game objects, referencing them through serialized fields, or using public instead of this. So I'll demonstrate. If I say public here, okay, it's exactly the same thing. So public, and then if I go into Unity, game controller does not contain, let me save. Yeah, so because I changed that on cat, oh no, it is here. What is this saying then? Game controller does not contain a definition for and no accessible extension. So it's saying that it can't find that script. So let me just see if I've made a mistake. Oh, I didn't save this. Silly me. See, there's a little star here, so it shows that it's not saved. This one was saved, but I'll just Control S again anyway. And now that error is gone. If I click on my cat object, it has the cat controller script, and it still has that reference to the game controller. And how did I attach this? Well, if I say none, so now it's looking for a game controller, which is handy. It's telling you there. I can just go onto my game controller and just drag that and drop it. And you see it knows what type it's looking for. So it does all the searching for you. So it will come onto this object. It will look through everything in the inspector and find the related type. And it finds this. So it will say, okay, that's what you wanted, obviously. So let me just add that. Cool. So I think that's pretty straightforward in terms of adding force movement to the cat. The only tricky thing is understanding that we need to get a direction and not the position. Yeah, but otherwise pretty straightforward. Okay, so moving on now, we're going to do the force movement of the mouse. So we want the mouse to move to the cursor. Okay, so currently it's working correctly. Why is the cat's not working correctly? The nothing's function's working fine though, so that's good. Let me see if I've broken something. Let me just, oh wait, hold on. That is not good. That is a problem. So let's see what I've done. I forgot to change this, right? Silly me. This needs to be what? The direction now. Because now we want to move in the direction that moves us towards the mouse. So now if I run it, hopefully it's working correctly. Otherwise I have very few answers for you. There we go. Okay, it's moving towards my mouse. Cool. Now it's not extremely intelligent, but it's a different way of doing movement. So that's why I thought it would be a fun way of adding it in. Okay. So I could just do something similar where we add a force in some direction to the mouse, but I thought it would be, let's move it on and make it a little bit harder. And in terms of moving my object towards the cursor. And I thought this wouldn't be so hard to do, but I ran into quite a few different problems that it wasn't working. So if I go into my mouse controller, this is the solution that I got in the end. But how did I find this solution? So once again, I just Googled around. So I just simply Googled how to move object or towards cursor or mouse, I think maybe it's better, in Unity. How to make an object move towards the mouse pointer. That sounds reasonably good as a solution. How to move object towards mouse on X and Z only. Sounds interesting enough. Move towards mouse infinitely at a constant speed. To make my rigid body move towards mouse position. Move towards. These are all valid things. And I went through all of these. And what you need to do when you have these problems is, I like to think of it, maybe other people would say this is wrong, but I think you look in a breadth first search in the beginning. And what this means is when you see a solution here, so this seems like a reasonable solution. Get mouse button, input, target position, position Z, transform, move towards. These seem screen toward points, whatever that means, I don't know. I do know, but I'm just saying reference twice. I like to try implement this solution as quick as possible, as easy as possible for my specific solution. And if it doesn't work, then just go to the next tab, basically. This one looks like, immediately I'm thinking this looks really complicated, I don't like it. But then I look at this answer, best answer as well. I will then maybe look at this as I'll try implement this as quick as possible. If that doesn't work, I'll move on in like this breadth first approach. And like this is another type of approach. They seem to be using the screen to world points a lot. Transform that look at, and then okay, this is a translate solution. But that's my idea of solving these issues. Oh, here's one that's cool. World position, direction. We've used this direction thing a bit, and then add force in the direction. Okay, that's interesting. So the general, if you go through these a little bit more in detail, they generally say, this one's maybe a solution that I haven't looked at before. They generally say we need to get the position of the cursor, okay? Then we need to calculate the direction, and then we need to add the force. So we've calculated direction. We know how to do this. We take the object that we're trying to move towards, and we subtract my current position, and then we just apply that as a force. So these two components are pretty easy. I'm sure you guys would agree. So now in the back of your head you're like, okay, well I can do this end part of the problem, but what is this part here? How do I get the mouse's position? So this could then be a separate like Google search. Instead of how do I move object towards the mouse, it's like how to get cursor position unity. And again, there'll be like multiple solutions, and then there's this one, right? Input.mouse position. And so then you just go, well, how is it utilized? Well, they have this ray thing. Well, I don't know what that is equal to camera main screen to point ray. Okay, so it's saying screen to point ray and then input mouse position. And then if physics raycast, so that's like not really what we want, but maybe this camera to main screen point to ray thing is something useful, and input.mouse position seems really helpful because that gives us the position of the mouse, but we're not sure in what coordinate space it is in. Is it in the world space, or is it in like that UI space, the screen space that I talked about last week? So, but what I'm trying to show you here is this is like the approach that you go along when you're stuck and you're trying to figure these things out. Here's another one where they say, okay, well, we get the position of the mouse, and now we need to convert it from like this screen space into a ray, and then if the ray hits, well, then we can move up, transform towards that hit position. And this is the solution that I implemented. So I'm actually glad I found it again. So I'll show you how it works. So inside our updates, because we want to keep updating, the mouse is going to keep moving, so we need to keep updating the target that we're trying to aim for. So I utilize that input.mouse position. So this gives me a vector 3, so an XYZ coordinate of the mouse. But this mouse space, this mouse position is on the screen itself. So it's not in like the world space of the object, it's in a screen space. So it's like a separate space of X, so they don't map perfectly to each other. And then what I say is, okay, well, I know in screen space where my mouse is. So let me then say, use this function called screen point to ray. And what it does is it converts my position of my mouse into a ray. An array is just like a light you shine, or like a line drawn not actually drawn, but like it represents a drawn line. And what I want to do with this line is I want to draw it so that it points towards my game world. So that's what I'm doing here. I'm taking that point, that cast point, and I'm shooting it out. And this is just like a built-in raycast function, this physics.raycast. So you only have to really worry about this, and then these you can just leave as is, leave that as constants basically. And now I want to get my direction based on where that ray hits. So it's going to shoot this ray straight down from my screen into my game basically. And whenever it hits an object, so it hits something that has a collider, I think it has to have a collider, I haven't tested that, it's going to return this hit value. And this hit value, if you say hit.point, well then it returns a vector. So hit is a variable type raycast hit, and it has a field that's called .point, and that returns a vector 3. So now I have a position in world space of my mouse, and I can just subtract the current position of my, this is the cursor and then this is the mouse, right? And then I can get that direction, and I can apply the force in that direction. Now how you get to this variable, there's multiple ways to do it, but this is one way that I found that was kind of cool. So I'll show you how that works in the game, or how it's working in the game. So if I run, so now if you think about this, wherever my cursor is, it's shooting a line directly down, and when that line intersects with an object, it's then it gets that position of that intersection, right? So it's always going to return a position on like my brown floor. Now if I move my my mouse over the white component, it's going to return a position on top of this white guy, right? Now because of the physics of this thing and I have gravity, I can't move to the top even though I really want to. Another thing that's interesting, so what happens when I move off this thing? Well, if I move here, I'm no longer registering any hits, so my mouse doesn't move anymore. I hope that makes sense, because there's no object for it to collide to if I'm in this like gray area. So it's no longer returning any value for that value of hit. Now if I move here, it does return a value, because remember this had a collider on it. Or maybe it does, does it? I'm not sure. But that will be a good test to see now. This definitely doesn't, and you see it's not recording any hits. So my mouse just carries on traveling with the force until it dissipates. So hopefully I've demonstrated this so you understand what's happening. So once again, a line being drawn straight down. So if you think of my mouse or my cursor itself being like way higher up than where it actually looks like it is, because it's like in 3D space, then think of a line being drawn straight down from that until it hits the brown like floor, or it hits anything with a collider, and that gives me my point value. Does everyone understand that? I'll take silence as a yes.
Yep.
Okay. Cool. But like I said, there's multiple ways to do this. Now on collisions, I've done this on collision stuff with you last week. I just used the on collision enter, but now instead of having enter 2D, because I had 2D collisions last week, it's no longer got the 2D, it's just on collision enter. You don't have to put 3D, it's just no 2D at least. And then I do the same thing. But the one thing I've added here is tags. So I don't think I added tags before. So what a tag is it's a way to like name your objects without actually changing their name. So how you do that, you click on an object and you can go to this tag field on the top right here, and you can change it to different things. I've changed the cat object to have the tag cat, and I can add more tags by clicking add tag and then clicking the plus, and then just say this is like hi, whatever. And now oh sorry, I didn't say okay, or save, sorry. And I go save, and there you go. Hi is now another tag. Now the reason this is done is when you created objects in the previous game, you saw their names change to like clone of cat, clone of ball 1, something like that, clone 1 of ball, stuff like that. And that's because when you instantiate prefabs multiple times, they become clones. Their name changes to like clone and then a number and then the name of the original thing. But if you set their tag to be something like a specific thing here, and you clone the object or you make copies of it, the tag will always remain as tag, as whatever the tag was. So cat will always be cat for all of those objects. And that's something good to use, because I remember I tried to do something like doing procedural generation, like of a maze, and I couldn't reference the objects with their names because they always had different clone numbers and stuff like that. But I was able to reference them nicely using tags. So now in the code, if I want to say GG when I hit something called cheese or something with the tag cheese, I just say collision. So I get my collision object that was generated from this onCollisionEnter event. I say .gameObject. So this gives me the game object of the object I collided with. And I say .tag. And this returns that tag string variable. And I just say if this is equal to cheese, then say GG. Else, I could say else collision. Oh, well, I do actually. Else, so if it's not cheese, if my collision is with something with the tag cat, I say .log rip, and then I destroy this object. Basically, I destroy myself. Cool. So that is it for today's tutorial. I hope it all makes sense and it's like kind of understandable, and it's adding on an additional tool that you can use. Things you can do with this one is increase the speed of how these guys move, and that's a little the little clue for that is something to do with that direction vector. So you increase the force that is applied. Now something you might have noticed that also kind of gives it away, if I come down here and then I go here, you see my speed's very fast. I even collided and popped over the world there. And the reason for that is, well, that direction vector also has a role on how much speed I add. If I have my mouse very close, you saw the speed was very low. So that's a clue for how to increase or decrease the speed. Other things you can do is add knowledge from previous weeks, like spawn in multiple cheese objects, add in some random positions of like another spawn for cheese. You can also look at the asset store for maybe a cat object or a mouse game object. And something that you can do to add a new mechanic to the game is add another, like a pull, like a sphere. So oh no, sorry, a capsule. So you can add like a little capsule object, make it maybe smaller, and this could be a hypothetical like a power pull. So if the mouse eats the pill, then maybe it can eat the cat, kind of like how Pac-Man basically works, right? So those are some things you can look at doing for this one. Now what I'm going to be doing next week is basically demonstrating a third way of doing movement, and that's through the use of our what is it called? I'm actually drawing a blank. Navigation meshes. That'll be through the use of our navigation meshes. So that'll be quite an interesting tutorial. Yeah. But otherwise, that's it for this one. I hope you enjoyed and learned something a little bit at least.